Good morning, everybody. My name is Dr. Dennis George. I'm the Executive Chairperson of African Quartz. And my topic for this afternoon is to talk about the importance of beneficiating quartz into silicon to manufacture photovoltaic solar panels in Southern Africa. If a person wants to find out what is the problem initially, and from South Africa's perspective, is that South Africa still faces a legacy problems and other severe challenges in our national drive to create jobs, to alleviate poverty, to address historical inequality, and to build a sustainable future for all our people, specifically in the Southern African region. To this end, the country needs a strong manufacturing sector. Our economy cannot achieve our goals on the basis of importing most of the products that we use. So a thriving manufacturing industry creates jobs, business opportunities, enables skills development, and improves our competitiveness in the global markets. Putting South Africa first should therefore be the priority of every South African. So in the first stage, the silicon purification from silica COR2 is found in quartz sand or lumpy silica. The ultra high purity requires for the photovoltaic industry is 99.999% purity. It is obtained through a heavy and high energy consuming chemistry process. The silicon material is not just used in the crystalline PV, but actually for the semiconductor industry also, for an example, microchips. However, the demand for polysilicon for crystalline PV is so high that 90% of polysilicon production goes into the PV industry. Stage 2 deals with the ingot and wafer manufacturing. An ingot is a cylinder or a brick of silicon, is grown from pure silicon, and it can be a single crystal or called a monocrystalline silicon or monocrystal silicon, or multiple silicon crystals that are smaller and the material called polycrystalline silicon or polysilicon. Then used by sewing diamond cutting machines, and the ingots are slid into thin layers of wafers. The secondary process is involving the polishing to remove the cutting from the wafer. The third stage deals with the cell production. To form the cell, two differently doped wafers are assembled together to form the so-called PN junction responsible for the photovoltaic effect. And the top and the rear metal contacts are applied, and many treatments and or modifications in the process can be applied to increase the efficiency of the cell. Stage 4 is the module manufacturing. The cells are soldered together, the electrical junctions being done by hand, or it can be done automatically. My recommendation would be that that should be done automatically. The cells are then encapsulated in a glass sheet to form a module, which is then cooked in a laminating machine. And then the final stage, stage 5, is the system. The modules are combined with the complementary equipment, such as the batteries and or the inverters, to deliver the electricity to the loads for electrical consumption devices or for the electrical grid. And this entire process, in conclusion, deals with the 5 production steps on the production equipment, which plays a critical role, a crucial role in the spatial transfer of the technology in the PV industry. And this is the most important part, and this is the reason why many African countries are importing the modules, which could easily be manufactured in Africa. In other words, you apply the 5 steps and you add in the beginning, you can add a mining part, and that will create sufficient amount of electricity that can be generated, the electricity is clean, and then in the downstream part of the supply of the supply chain focus on the market services involving with actual installing, operating, and financing PV systems. And to give you an overview of the downslide side, so it will basically bring together the upstream, and it will also deal with the downstream. So on the left-hand side, you will see PV models, and I've just explained to you the 5 steps that come before that. I also explained to you the inverters and the support structures and trackers, and then the basic operating systems. And all these processes can be brought together so that the electricity crisis that is found in Africa, where more than 500 people are without electricity, could benefit, but then it will require the countries, to cooperate with one another and to work with one another. And by doing this, we could address the problem of energy in Africa, and even for rural areas, the process would be good. From my side, thank you for the opportunity to listen to me. Thank you.